And so the last short run average cost curves that we have is the average total cost, so ATC. So what is average total cost? Average total cost is the total cost, divided by the number of units of output that is produced. So this cost we are talking about average. So average means it will be divided by something. So what are we dividing here? We are dividing the total cost by the number of units, that is output that is produced. So to get average total cost, we divide the total cost by the level of output that is produced, or ATC equals total cost divided by output. So Q represents output. And again, we have discussed that total cost is equals to total variable cost plus total fixed cost. So since TC equals TVC plus TFC, we can rewrite this formula. So ATC equals, so you represent or substitute these TC values by these two and divided by Q. So TVC divided by total variable cost divided by Q plus total fixed cost divided by Q. So we are, distributing Q in both the terms. What we have is total variable cost again divided by Q is average variable cost. And again, total fixed cost divided by Q or output is average fixed cost. And so average total cost is equal to average variable cost plus average fixed cost. So ATC is also known as the unit cost because it is cost per unit of output that is produced. That is average total cost. So we are adding both average variable cost and then average fixed cost, and that what we got is the average total cost. And again, let us explain further this figure 2. So here ATC is the average total cost, and like average variable cost, it falls in the first place and then it rises steeply in the second phase. So it is somewhat similar with the property of the average variable cost. And as I have just mentioned earlier in the previous class, as output increases, so in this diagram we are measuring output on the x-axis and we are measuring the cost on the y-axis, and 0 is the origin. And so as output increases, what happens to ATC and AVC, average total cost and average variable cost? What happens to both this curve? So as we increase the level of output, the vertical distance, between ATC and AVC keeps on declining. So this vertical distance keeps on declining. So that is the relationship that occurs between ATC and AVC curve when output increases. And what happens between average variable cost and average fixed cost and average variable cost as output increases? So as output increases, average fixed cost becomes smaller and smaller. So this cost is becoming smaller and smaller when we increase the level of output. And when this AFX is approaching the x-axis, average variable cost is approaching near average total cost. So that is the relation that they have between average fixed cost and average variable cost. When average fixed cost is approaching towards x-axis, average variable cost will approach towards the average total cost curve. So that is the explanation for the diagram or for the figure 2. So this average total cost can be obtained, or since it is the sum of average variable cost and average fixed cost, we can obtain the average total cost, by summing up the column. So how do we sum up? By summing up these two columns, average fixed cost and average variable cost. By summing up this 5 and 6 column, we can get average total cost. So average total cost at unit 1 is 50 plus 20, so that is 70. And at 2 units of output, average total cost is obtained by adding 25 plus 17.5, then we get 42.50. And at unit produce at 8 level of output, the average total cost is obtained by adding 6.25 plus 35.50, that is average fixed cost and average variable cost. So when we add these two, we get 41, that is average total cost. And alternatively, the average total cost can be also obtained by dividing the total cost by the number of units of output that is produced. So that is another way of obtaining average total cost. So we divide this total cost. So we divide this total cost by the number of units that is produced to get the average total cost. So what we get when we divide 85 by 2, what we got is 42.50. So it is the same whether we add up this column 5 and 6 or when we divide the total cost by the number of unit that is produced, the answer we get is the same. So average total cost can be obtained in two methods. That is, we add up column 5 and 6, that is average fixed cost and average variable cost are added up and we get average total cost. Alternatively, we can also obtain this average total cost by dividing the total cost by the units of output that is produced. So it follows from the above discussion that the behavior of the average total cost, this average total cost will depend upon the behavior of the average variable cost. So this behavior of ATC curve will depend on the behavior of AVC, because this AFC, average fixed cost, is not going to affect this ATC because this is fixed. This average variable cost will decide the behavior of average total cost. So in the beginning, what you see is both this ATC in AVC falls in the beginning, and the ATC curve therefore falls sharply. So in the beginning, since AVC falls, automatically this ATC also falls in the beginning. And when AVC curve begins to rise, so when this AVC begins to rise, this ATC will also rise. What? So when there is an increase in output and we have increased the level of output, so when that happens, there is a sharp rise in both AVC, which more than offsets the fall in AFC, Therefore, the ATC curve rises after a point. Thus, the average total cost, like the average variable cost curve, first falls and reaches its minimum value, and also after that it begins to rise again. So the average total cost curve is therefore almost of a U shape. So this ATC curve is looking almost like a U shape. And like the average variable cost, it falls and then touches the minimum and again it rises. So the behavior of average total cost is shaped or dependent upon average variable cost. And one important point that you have to note is when average variable cost curve begins rising, when this AVC begins to rise, AFC curve is falling steeply. So when this is rising, this ATC is still falling down very steeply. This ATC curve. The ATC curve continues to fall even if this AVC begins to, or it starts to rise. But this ATC is even more falling down. This is because, during this stage, the fall of average fixed cost curve weighs more than the rise in the average variable curve. That is why even when AVC started to rise, this average total cost even falls down more steeply, because this AFC, the fall in AFC curve, weighs more than the rise in AVC. Since the fall in AFC is much more higher or bigger or stronger than the rise in AVC, the average total cost curve even falls further when this AVC begin to rise in the beginning. But after reaching a minimum point, the ATC begin to rises. And that is why this ATC curve looks like a U shape. That is the relation that they have between average fixed cost, average variable cost, and average total cost.